Hello. Today I want to talk to you about two of my favorite things coming together, helping animals and industrial engineering. It's called an MM1KQ. Don't worry, no calculator is required. There will not be a test. But this little equation is actually going to give us a very good understanding of what happens inside animal care services and why simply saying we need more space doesn't actually solve the underlying problem. So let's break it down. First off, what is a queue? Well, it's really just a fancy way that engineers and British people refer to a line. Think about checking out at HEB. Customers arrive, cashiers serve them. If customers arrive faster than cashiers can check out, the line gets longer. ACS works pretty much the same way, except instead of customers, we have dogs and cats coming into the system. And instead of cashiers, we have staff, veterinarians, adopters, rescue partners, and foster agencies working to find homes for those animals. The shelter has a finite number of spaces, and so that puts a hard limit on the number of animals that can be in the system at any one time. So in the equation MM1Q, that first M is what's called the arrival rate. Now it's an average per day, but that average can go up and down. On any given day, the number can be higher or lower. Nobody expects to find a litter of kittens under their back deck, but these things happen. And so that number is intended to represent an average number with some variability to it. The second number is the average number of animals that are sent into homes or moved out of the ACS system on a given day. The one is indicative of the fact that we only have one ACS in Corpus Christi. And then the K, that's the very important number for our purposes. That's the capacity of the system. So maybe we have 100 kennel spaces in the system. And once you get to animal number 101, now you don't have any space. So that's where the system gets tricky. Within that, we have that arrival rate number. That's called lambda, and a service rate number. That is mu. That is how many animals are coming in and how many animals are going out. And these are averages again, so they can go up and down. But if lambda is smaller than mu, then we have an ideal situation. That means we are able to rehome animals faster than we can take in new animals on average. And that gives us the ability to recover if there's a spike for some reason. Alternatively, if lambda is bigger than mu, that means now we're accumulating animals and we have a problem. So if we think about it from that standpoint, we go back to the 100 available spaces. If we have 12 animals coming in on average every day and 10 leaving, then after one day we have 2 animals. After 5 days we have 10. After 20 days we have 40. Eventually we run out of space. Doesn't matter how big the space is. That's the K in the MM1K model, right? And historically, when we hit that K number, that's where animals end up being euthanized for space reasons, and that's what we want to avoid. So thinking about it another way, if you have a bathtub that you're worried about overflowing and it's taking in 12 gallons a minute out of the tap, but the drain is only draining at 10 gallons a minute, even if you make the bathtub twice as big, all you've done is delayed the problem. It's still going to overflow. You have to fix the flow rates and get either that input down or the drain working faster or both. So what actually fixes our problem? Again, it's not just building space, it's reducing the number of animals coming into the system. That's trap, spay, trap, neuter, release programs that reduce the rate that our feral animal population is increasing. It's programs that help people keep their pets and not have to surrender them. It's things like microchipping and reunification programs that increase our rate of people getting their pets back when they get lost. And then it's education, making sure people understand the importance of spaying and neutering pets. I think there's a perception in some parts of the community that maybe this is cruel or inhumane, but it's really what's best for animals everywhere if we don't increase the number of unwanted pets. On the other side of the equation, we have tools to try to increase the rate that we are moving animals out of ACS through more partnerships with rescue organizations, more resources to help streamline any bottlenecks in the processing. And then also one thing that I think is really underutilized today is more marketing to let the community know about the availability of these animals, that they're great family pets, and that that's an option. All of those things help us drive up that MU number. And that's really what's going to help us make the system work better and be more robust. Now, that doesn't mean that we don't still need spaces. And here's why. There's an interesting part of queuing theory that we call buffer capacity. Now, just because we can process more animals, get more animals homed than we take in on a typical day, doesn't mean there aren't going to be weird spikes that happen. We could have a hurricane. We could have a large seizure from an animal hoarding situation. And in those scenarios, we need capacity to house those animals. And that's why it's really important that we are not running at 98, 99% capacity all the time, because then we don't have the ability to absorb these kind of spike events. So a well-designed system actually runs at least proportionally empty for a large part of the time to ensure that we have spare capacity when surge events happen. So we're not just measuring how many spaces do we have and how many of them are full. We need to be tracking the right things. What KPIs really matter? And that's how many animals does the shelter take in and at what rate? And then how many animals are leaving? What is the rate that we are finding homes? Then of the capacity we have, what is the utilization of that capacity? How full is the shelter on an average day? What is our success rate of returning lost animals to pet owners? These are the kinds of KPIs we need to measure. It needs to be a data-driven system that looks at all of the different parts of the system and how they work together. Animal care services, as an engineering problem, needs to be asking these bottleneck and process-driven questions. Once we understand the system, we can start making decisions for how best to optimize the system based on real data and not just anecdotes. That's the key. Because if we think about it, engineering problems show up all the time, and we've been solving them for decades, whether it's traffic, manufacturing, hospitals, airports, and things like animal care services. They're all systems. They all have inputs. They have finite, limited capacity. They have bottlenecks. They have queues, and they have outcomes. If we want better outcomes for animals, we shouldn't just ask how much money or how much space we're putting into the system. We should ask, how do we design a system so that it actually works? Because the goal isn't just to build a bigger warehouse for unwanted animals. The goal is to find homes for animals and reduce the number of animals we have to have in the system. I'm Alex Johnston, candidate for City Council at Large. Data over drama, better systems, better outcomes. Thank you for your time.